Well, at long last, it's time to write a program. And we're going to start out with a program that just makes the robot move. So I'm going to give the new program a name. We'll call it Move. Let's close down the Robo Center so we get some more screen space. The block that you'll use the most is this Move block. And so I just click and drag it out here. When the Move block is selected, you notice that the control panel down here gives you lots of information about what you can do with that move block. What's cool about it is that a move block controls more than one motor at a time. In this case, it'll default to motor B and C being involved in moving. If you don't have a good reason to change it, I'd go ahead and just say that B and C are going to be my motors that move my robot around. The reason for that is that if you change it, you're going to have to, every time you drag a move block out, you're going to have to change these settings and these settings. So you may as well just save yourself some trouble. The fact that I've said that B and C are involved moving the robot means that C and B are selected down here. If you can just say that motor C is always going to be on the left-hand side of your robot and motor B is always going to be on the right-hand side of your robot. That's left and right hand as if you were sitting inside the robot as a little tiny Lego person. The wheel on your left is going to be the wheel that we're talking about over here. Again, if you change these, you're going to have to change it every single time you drag a move block out, so it's better just to plug them in this way. The direction of the robot's movement is controlled here, and it thinks that it's going to be defaulting into going forward, and that may be the case in your robot, but it really kind of depends on the direction that the axle's turning on the motor. So I'll bring up the help and I'll show you what I mean. Yes, I know that it would be okay to display this active content. If you get tired of seeing that, by the way, what I usually do is the first time I bring it up, I have to answer that question. But then after that, I just minimize the help as opposed to closing it. Then every time I bring it back up, it comes up and it doesn't ask me that annoying question every time. Anyway, back to what we were doing. So here we have help on the move block. I'm going to scroll on down to the middle of it here where we have a nifty picture of the motor. When the move block says move forward, that's the up pointing arrow that we saw before, it means that this axle here is going to be turning clockwise. So if you can construct your robot in such a way that a clockwise movement is the forward movement of your robot, well, then that'll be great. If you have to build it in some other way, it's not a big deal. It just means that every time you drag one of these move blocks out, you're going to have to remember that, well, forward is really down and backwards is really up. The other thing you can do here besides moving is stop. There isn't a separate block for stopping the robot. You do it here. So whenever I selected stop, it still looks like a motor move block, but it's actually telling the robot to stop. And the way you can tell is by the icons down below here. Now that I've selected stop, I've got the stop icon. If I told it to go forward, now I've got the forward. It's kind of giving you a shorthand view. It gives you a shorthand view of what the power is. It gives you a shorthand view of how long that thing is going to be running. We'll talk about that in just a sec. And what motors are involved. Going back down to here, if I, instead of wanting my robot to go forward, I wanted it to turn, I can drag the slider around. If I drag it all the way to the right, the robot's going to pivot in place. If I drag it one notch up from that, then it's going to stop one motor. In this case, it's going to stop motor B and make motor C go forward. So the robot will kind of turn at a little bit less sharp angle than it would if it was all the way over to the right. And then dragging it to different places, the robot will tend to veer one way or the other. The power that the motor is going to have to work with is controlled here. And if you wanted to go at full speed, you drag it over here. It'll start out being 75%, and you can drag it up and down. Depending on how much accuracy you want out of your robot, you may find that lowering the power is a good thing. Sort of like if you were driving your car along the freeway at 60 miles an hour and then did a sharp right turn. It would be pretty exciting, and the car would sure turn fast, but it might not be the most accurate thing in the world. And so you'll have to play with this depending on how much accuracy you need versus how much speed you need to get the right balance. The other cool thing about the move block is it also lets you get an indication of how far the robot's going to move before it goes on to the next block here. And that's done here. It'll start out thinking in terms of rotations. So this is one complete revolution of the axle that's plugged into the side of that motor. If you have some gears involved or whatever, it won't necessarily be wheel rotations. But if your wheels are just hanging straight on the side of the motor, it'll be how many revolutions of the wheel. You can type 1.5 rotations if you like, so you can get whatever accuracy you want. You might also like thinking in terms of degrees. In this case, 1.5 revolutions would be 540 degrees. This number can be as big as you need it to be, and so some people just like to just think in terms of degrees all the time and say, well, I'm going to move 3,024 degrees, and that tells them how far the robot's going to go to a pretty high degree of accuracy. You can also think in terms of time. It will default to its best guess of how long that's going to be. Depending on the load on your robot's motor and such, that may not be the most accurate thing here. Usually for like a first Lego League competition and such, you would think in terms of rotations or degrees and not in terms of time. The reason for that is what happens if your battery's a little bit less charged one time or another. If you were thinking in terms of time, well, it's going to travel a little bit less far on your mat, and that's usually not what you want. However, time is a really good way to indicate how far a motor should turn. If there's a chance that the robot might get hung up doing something, like let's say you were pushing something around on a first Lego League course and it ran into the wall. Well, if you were waiting for a certain number of rotations, then those rotations may never come because the wheels are jammed on the surface and they're not turning, and that could be kind of embarrassing. So in those cases, thinking in terms of time is a good idea because it's going to push as hard as it can push given the power level that you set for this much time, and then it's going to stop and go on to the next block on your program. The next action is what's going to happen when this condition is satisfied. Break means as soon as 8.4 seconds have gone by, in this case, the robot's going to come to a complete stop, and then it'll go on to the next block up here. If you're stringing a whole bunch of blocks together, then you might want to coast between them so that the robot doesn't come to a complete stop every single time you go from block to block. So coasting just turns off the power to the motors, but doesn't turn on the brakes. Okay, so what I'd like you to do right now is to drag some of these blocks out here and make your robot do something fun. Go forward for a bit, and then maybe on this one you'll tell it to turn, and then on this one maybe you tell it to turn the other way. You can change the rotations here. Maybe make some of them degrees and some of them something else. Oh, by the way, we do have this unlimited function. What that does is say, okay, this motor is going to turn on, and in this case it's going to turn for at power level 75, and it's going to do that until my program tells it to do something else. So the program's going to start all this happening, then it's going to go on to the next block. That doesn't make so much sense here when we're just talking about move blocks, but once we start talking about sensors, you'll see where you might very well want to start the motor up and have it going and then wait for a certain sensor action to happen. So go ahead and write a program, and then we'll be on to the next lesson when you're done with that.